All right. Shh. All right. I don't know what is going on with the TV, so I apologize. How are the recordings been?
Good.
Yeah. Oh, I hear mixed reviews. No? Yes? The recording?
They're very helpful, but sometimes the feedback is a little much on them. Or like if we ask a question, it won't be heard.
Yeah, the question thing isn't gonna. You gotta shout if you want to be heard. But yeah, we're trying to get this microphone working. He was testing it before we started, so hopefully next week we got it. But some of you guys were asking about exporting views and printing. So some of you were printing from sheets. Some of you were printing from sheets. Others were printing from views. For what we're doing right now, I haven't actually shown you how to put together sheets. So just for right now, print directly from views. And there's a couple things you got to remember when printing from views. So everything, all of your annotation elements, all of your sections, your elevations, your callouts, all that good stuff, all of that, the sizing of them and the sizing of your text is controlled by the scale of the drawing that you're in, the view that you're in. So if the scale is larger, let's say 1 inch equals a foot, all of your annotation is going to be very, very tiny compared to if your scale is much smaller. Let's say 1 inch equals 100 feet. Reason being is because the level of detail and the size of those sheets are growing in real life. So the scale of those drawings are getting larger or smaller depending on the scale of them. And all of the annotation devices are all based around real measurements. So 3/32 inch tall text has to be 3/32 of an inch tall text no matter what the scale of the drawing is. So you got to be cognizant of that. So when you create it larger, it makes smaller. Make the scale smaller, they make these larger. So you want to make sure that when you're exporting, you find a balance so that Allah can actually read what's going on and that he doesn't have giant call-out heads blocking the majority of the drawing. And then what I find works best, especially for what you guys are doing, make sure that you crop using your crop view exactly what you want to export and make sure that it's actually cropped, right? And then when you go to print, make sure that you choose the correct size of the paper. But then also, I always do fit to page and center it. That way it will fit whatever page you're doing, and you can preview it under preview. And you should be able, unless you're printing multiple pages or multiple views, if you're just doing a single drawing, you should be able to preview what it's going to look like when it prints. Okay? Does that make sense? Anybody have any other questions on exporting views? We'll get into laying out sheets when we get into more of the graphic representation part of the Revit course. Cool? Okay, so today, curtain walls and curtain systems. We're going to be getting a little bit more detailed into it. So go in. By the way, this is my house, in case any of you wondered what the floor plan of it looked like. Let's go open up our template. Everybody got it open? Cool. All right, so we're going to create a conceptual mass, a double curved wall conceptual mass. So let's go into the massing environment. Under massing and site tab at the top, go down to in place mass. I always think that you're raising your hand. It's freaking me out. It's okay. All right. And then draw 3 straight lines. Doesn't matter what the distance are between them. The 4th line will be a spline. So, well, you can either do a spline or spline through points. Either way. One is the NURBS-based curve. The other is your exact control points. And then just draw a double curved line. All right, all of this should be done in level 1, and when you highlight over that curve, it should all be selected. That's how you know that it's a joined curve, closed curve if we're talking about Revit. All right, and then what we can do, instead of going to a higher level and redrawing this, what we can do is we can click our curve and copy it. All right, and then pasting, you can paste it the traditional way where you just Control V and do the, oh, this version of copy, copy in the Modify tab is completely different than the Control C copy. All right, so Control C this guy, so it copies to the clipboard. All right, and then under paste there's a drop down arrow. So there's several things that you can do. One of those is aligned to selected levels. So that will take that curve or whatever element that you selected and copied and paste it to that level. So what we want to do is take this curve and copy it to a higher level. So if we do align to selected levels and then highlight the roof level, if we press OK, it will then paste directly above the original, but at the roof level. So under the clipboard, there's a paste. There's a drop down under the paste.
My paste is grayed out.
Your paste is grayed out. Did you Control C? So that means that nothing is actually copied to the clipboard. You gotta hit Control C.
So if you're on a Mac, Control C doesn't work. You have to use the copy button in Revit. Some people are on a Mac trying to reuse Revit on Windows. So what's it called? Bootcamp or something?
Bastards. Okay.
And Control C doesn't work.
Okay. All right. So if you select something, so I've never used this before, so bear with me. But the 2 pieces of paper, copy to clipboard, click that. See if that works. Although you don't have a Mac, so that might be.
Oh no, it was just grayed out when I clicked on it. It worked.
It worked? Okay. Alright. Everybody on here? Alright. So, one thing we want to do to make this a true double curved wall. So we're going to be creating a mass from these 2 control points. We're essentially going to loft them together. So what we can do is manipulate, actually, whoops. Let's tab through and delete this one double curve. Yes. I thought I saw a hand raised. Man, who knew copy pasting was going to cause this many issues?
Hold on, go ahead and shoot that.
Are they 2 different? Yeah, you want to check that in a second. Don't even ask.
Oh my goodness. Okay. This is gonna be a fun class. All right. So then. All right, everybody's waiting. Okay. So right now, I just realized that we're still drawing on the first level in 3D. So we need to change the plane that it's set to. So under set, up at the top, set work plane. Change that to placement plane to roof. And now just create a new double curve that's different from the one at the bottom. And actually make sure that you have those covered.
Can these lines and lines, do they snap at all, or is it just you just have to kind of know where you're placing it?
So that is one of the issues with the if you copy or mirror or offset the splines, they lose all adjustability, and that includes snapping too. So typically the original ones are decent, like they actually have control points that you can snap to, but if you do anything to them, they lose that. That's one of the big drawbacks of the spline tool. All right, so if we select both of those and then hit create form, now we have a double curved face. Just go up with. Oh, that's
Oh, it's not mine.
Yeah.
Garrett, did you do more steps?
Yeah, to be a little more specific. Did I do more steps?
Did you like
Since when?
Since the copy? Yeah, you just selected them and extruded.
Yeah.
Okay.
Like these two.
So now to get to where he's at, you have to select both and hit the extrude button.
Yeah, next time use just the regular lines.
Is everyone at where the screen is?
Okay, I can
All you need is this. That. All you need is that.
Select everything.
No, you have to press solid. Don't say get back in. Try.
All right. Let's try one more step. So, once we have a double curved surface, if you weren't able to do a solid, that's okay. All right, so we're going to apply a current system. So, finish mass. Go to architecture, and then current system. Select the double curved surface, and then create system. And we create a system. So I know you guys knew how to do this already, but we're going to go into a little bit more detail on the curtain wall and the curtain system and the different parameters that you can plug in, how you can manipulate it to be not just a typical glass curtain wall, but you can have any kind of panelized system. So first thing we're going to do right now, this is just a curtain system with grids that are panelized. So what we can do is go to the build tab. Oh, excuse me. Yeah. Go to the build tab, hit mullion. And if you hover over any of the grids, they will highlight. And if you click, it'll actually place a mullion onto that grid.
Where's the build tab?
Oh boy. So under architecture, under build, so in the same panel as wall, roof, and floor, the far right is mullion. God, I gotta be more descriptive. Sorry. So hit mullion. Yeah. And then under the mullion, place mullion, there's 3 different types of placements that you can have. There's a solid grid line, so it does the entire length of the grid, whether that be vertical or horizontal. A grid line segment, so let's say we only wanted to box out this specific panel, we can do that. Or if we wanted to do all the grid lines all at once that don't have a mullion associated with them, click that and they will all be placed. Everyone follow that? Thank goodness.
Such a little sass.
No, it's just, I think we're on line 4 of 30. Huh? Yeah. So the glass, just to be specific, so especially with a curved wall and more specifically a double curved wall, anytime you create a curtain system, the panels within them are going to be flat. They facet whatever geometry that you are applying it to. So that's why these guys stick out like they do. Okay, and that's just like the real world, unless your client has the money to actually pay for curved panels, which is not very likely. So one thing to do to counteract that is to change the depth of the mullions so they actually capture this little edge that sticks out. So if we hover over and tab through until we select one of the mullions that we've placed, right now it's showing up as a 2.5 by 5 inch rectangular mullion. If we go to edit type, we can start to manipulate these. And these can not only, they don't have to be mullions. I know they are specified as such in the Revit environment, but they can be vertical fins, they can be structure, any type of grid system that you can find on a building, they can be. I mean, they could be reveals, we'll create one of those. They can also be a lattice system. The possibilities are endless, kind of. So let's create a new type of mullion. So let's duplicate this mullion and call this vertical fin. Okay, so underneath the properties, you have several different options to manipulate. So angle is actually the angle. So right now, this is at 0 degrees. That is perpendicular to the surface at the position of the grid. So we'll leave that right now at 0. We'll change it at 45 later to show how that is manipulated. Profile. So if you ever wanted to change the profile of the mullion from circular, rectangular to a more specific one, you can do that as well. Right now, system mullion profiles are profiles that you can edit. So rectangular, you can edit the depth and width. Circular, you can edit the, you should have been able, edit the radius. We'll stick with rectangular for now, since we want to create a vertical fin. What's up?
Nothing, I just want to see where you're at, because I'm super distracted.
Okay. So we're editing, it's okay. We're editing the type of mullion right now. Just manipulating parameters. So we want this thing to be a vertical fin. So 2.5 inch thickness is typically not what we want. So let's make this 1.5 foot. All right, and then width on sides. So these are asking for different widths. So it's taking the center line of the grid and measuring from that either on the left or right side. So the addition of these is the total width of the panel. So we can just put these to 1 inch for both, so that we have a 2 inch wide fin. And then mullion we can change if we would like to anything. Let's change it to copper for fun. And yeah, I know. So remember to change the material. It's that little ... button that doesn't appear until you actually hover over it. Doesn't matter what material you change it to. And for some reason, it doesn't want me to select anything. Okay. Okay. So if we press OK, now that mullion that we've selected has changed and updated to the dimensions that we put in it. But it is stuck directly in the middle. So if we go back into the properties of it, there is a parameter called offset. So that offsets the mullion from the face of the surface out or in, depending on if you put in a positive or negative. So since our thickness of our mullion is 18 inches, to be able to have that jut out as far as possible, we want to take half of the distance of that thickness so that it projects out. Because right now it's centered on the grid, so we need to move it half the distance of its thickness to get it to be on the outside face of the panel. So 18 inches is 9 inches. Press OK. And now it is outside where a typical vertical fin should be. Anybody need me to cover that again? Yeah.
Can you change the direction of the my phone is going up.
It's going up.
Yeah, it's not going out.
Oh, you selected it horizontal. You selected it
Oh,
horizontal.
I didn't.
Yeah. So you do
Yeah.
Okay, so
Well, so it should still be. So if we change this to the vertical mullet or vertical fin that we changed, it should be the same. Does that not look the same?
oh.
See, so it's. Did you
No,
change
it's
the
just
angle?
maybe because of the
It might be the. Select the. Alright. So, the other thing that you can do is adjust the angle of that vertical fin. So, edit type, let's say we do 45 degrees. We'll rotate that fin 45 degrees, perpendicular to that thing. And remember, it rotates on the center line of that mullion. So it's not gonna, that bottom edge is not gonna line up with the grid, unfortunately. Alright. So let's see. The rotation? So the rotation is the first parameter. You can either do positive or negative degrees. Same thing with offset, you can do negative. And it will rotate that mullion. It will rotate the mullion around the center line of the mullion. So if you offsetted it out, it's not going to rotate from the grid line. It's rotating from the center of the geometry of the mullion. It doesn't matter. I'm just showing you guys the extent of which you can manipulate the current wall system. Okay? So let's change all of the mullions, vertical mullions, to the vertical fin family that we created. Alright, so to do that really easily, I click and drag from left to right, select all of those vertical mullions, and then under filter, since in a grid system like this, you have many different elements within it, so it's good to be able to filter that out and only select the kern wall mullions. Okay? Uh-oh. What's up?
Did you pin the horizontal ones, or?
Did I pin them? No.
So you have them all?
I only selected. Sorry.
How is it not selecting the horizontal ones?
I think it's a cat. I don't know if it's in. Well, if you click and drag a box from left to right, it only selects the elements within the box. If you go from right to left, it selects everything that box touches.
Yeah, but how do you select multiple times?
You hold control. So if you hold control, a plus sign appears. You can select multiple elements.
That doesn't apply to my phone.
Oh, well, it should. Control is control.
Yeah, but when you're on boot camp, it might not.
It depends, because aren't you remoting into a...
Yeah,
Yeah, she should be fine.
Is there any way I can deselect something?
Yep, hold the shift key. Shift key is the opposite of the control key. You'll see a minus appear next to your mouse. And you can do the same thing. That's pretty standard across all computational software. Just FYI. Okay, so when you have those selected, then hit filter, kern wall mullions, and then change it to vertical fin. Yeah. This really sucks for... It's so weird. Now, oh. Anybody?
What comes after selecting them? What'd you do? Did you just make them longer?
Filter.
Just
select mullions.
Okay, and then you just wanted to make them vertical fins, right?
Mm-hmm.
Okay, so we changed them to the family, or that's the only thing he did, just like, so that's any.
I don't think it's gonna work for a future.
And the new family.
I think I'm gonna have to do video tutorials. Alright. So, now that all the vertical grids are our vertical fins, now we can change the horizontals. So the horizontals, just like you can create fins, you can create mullions, you can also create reveals. Reveals are essentially just mullions that are recessed within the panel itself. So if we go and select a mullion, go to edit type, and then duplicate that mullion, turn it to reveal. Alright, and reveals are typically small, so for our purposes we'll make it 1 inch thick. So our dimensions, our width on side 2 would be 1/2 inch, and same on the side 1. And then our thickness, it really depends. But since it is actually supposed to be a reveal and doesn't necessarily have a thickness, we can just create a small one. So let's make it 1/4 inch. And then just like with angles, we can have positive and negative angles. We can have negative offsets. So we can do, since our thickness is a 1/4, we'll do 1/2 of that, negative 1/8 inch. Now the front face of that reveal will be at the front of the grid. Press OK. Now we have a very tiny recessed reveal. Now, we could, if we wanted to change all of the horizontals to reveals, we could go in and do what we did for the verticals, select them all, filter through, and change the mullions. Or we could create, we can make it adaptable to the type, the current wall type, or current system type. So right now we're on 5x10. If you select, so highlight over one of the boundaries of the current system, you'll get a dashed boundary around the entire wall. If you click that, you get the current system under properties, should be 5 foot by 10 foot. If you go to edit type, in there, similar to all of the current walls that you should have been manipulating in past assignments. In here, you can change specific elements. So interior 1, interior type 2 for the mullions. Of course, it doesn't say which one is horizontal, so we'll have to just test it out. So under interior type for grid 1, let's test out, scroll down to reveal and have that selected. And then for grid 2, let's go down and select vertical fin. And instead of hitting OK, since we want to check to make sure that the horizontal, and the vertical is vertical, instead of hitting OK, let's just hit apply and see, of course, it is the opposite. So if we go back in and switch those around, grid 1 is vertical fin, grid 2 is reveal, and it may be correct on yours. It all depends on how you created the system. But now all of these are parametric to the system. So if you want to change the type of mullion for all the horizontals, you go in here, you can change it to whatever you want, press OK, they will all adapt. This is how you quickly update your model and adapt to it. Alright, so make those reveals. Yeah.
How come the border vertical mullion stays fixed?
So that is because right now our border, so along with the interior mullions that you can select, you can also do borders, and you can do each border as a different type of mullion. So right now we have none selected. So whatever that mullion was, it's going to stay like that until we go in and change the border mullions to either vertical fin or the reveal. And then you guys are familiar with the different types of grid: fixed distance, fixed number, max spacing. That's changing. It's because you missed a class. So fixed distance. So that is giving you a definitive distance between the grids, and will give you a leftover distance if that specified distance does not divide equally along the surface. Maximum spacing is similar, but instead of doing a fixed distance and giving you a remainder, it will divide that surface equally as close to that specified number. Minimum spacing is similar, but it will give you a larger distance. And then fixed number, if we press OK, so fixed number you cannot adjust in the type properties. Fixed number is an independent parameter that is an instance parameter. So each wall can have its own specified number. So if we change this from 4 to 7.
Garrett, for the reveal, just a quick question. Did you edit type on the mullion and just change the offset of it?
Yeah, so under mullion, so yeah, I made a new type. Yeah, good.
Thank you.
Yeah, and then instead of offsetting it positively, you can do it negatively, and it will recess into the wall. All right, so we changed that grid number from 4 to 7. That increased the amount of divisions of the grid system from 4 to 7. You can do that as many times or as little times as you want, depending on the wall and your preference. Okay. The one other thing that you can edit within the current system is the panel, current panel. So if we do a drop down, and let's make this all solid. Press OK. Right now we really can't see any difference because it's all in white. If we go to the bottom, there's a visual graphic display options. It's a three-dimensional box. If you hit shaded, you will then be able to see more clearly the different definitions of the panels. Okay. Yes.
Change panel. Did you select the whole system?
Yeah, so I selected the whole system, went into edit type, and then it's the first parameter under current panel. Alright. So that changed it all to solid. Now we can go in and edit the current panel, just like the mullion. So if we go into edit type, and then we can start to manipulate the different parameters within the solid. So we can rename this to metal panel. And then our thickness right now is 2.5. So let's make this a 6-inch panel. And then since we want the panel to be offset accordingly, we have to offset the panel by half of its thickness, which is 3 inches. And since this is a metal panel, our material is set to default. So if we go in and hit any metal panel, I'll hit aluminum for right now and press OK. Now we have a metal panel wall system with vertical fins and reveals for the horizontal joints.
What do you select one?
Select one panel. So just like every other element within Revit, if there's multiple elements, you have to tab through until you get the selection. And typically you want to go to the edge of a panel to be able to select it. If you do the middle, you won't get anything. So go to the edge, select. Now,
You did edit type and you offset.
yeah, so I made the thickness of the panel 6 inches. So I have to offset the panel 3 inches to make the surface project from the face of the wall. Now you don't have to do that. You could have it centered on the wall. You just have to be cognizant of where all of your different elements are in relation to each other. So let's say you don't want your glass floating out 4 inches off the wall and your mullion's back, and now it's just floating in space. Okay? So one thing. So I believe I mentioned this in previous classes, but with curtain walls and curtain systems, when you do edit the different parameters within the system type, so when we change the curtain panel, when we change the interior types of mullions, those now are tied to the family that they're associated with, the wall that they're associated with. So if I tab over and select one, you'll see this magnifying glass, the pin next to it. That means that it's tied to it, and you cannot change it unless you unpin it. Unpinning it by either checking the pin that is highlighted, or going up to the Modify tab and doing the pin with an X across it. If you do that, now you can change it to whatever different element that you want. But if you go into the current system and update your vertical mullions from vertical fin to something else, everything will change except for that one, which of course I made the same. So let me make it different. So I change it to vertical fin. All of them change except for that one. Does that make sense? Sure. That's very confident. All right. All right. So one more thing to do. Yep. All right. So now that we're done with this, we're going to get into something a little bit more complex, which should go over smooth. So let's save this project before we move on to anything else. I hope you know how to save. Is it going to crash your shit? Okay, that's good. All right, then don't save, I guess. I think, yep.
Guys, when Garrett says open up your template, he means open the template through Revit, through a project in Revit. Don't open it as a template to be manipulated, because
Yeah.
you can only save templates. You can't save projects.
Oh no. I did this the first class. You're supposed to learn from my mistakes. Go File, New, Project, and then it will open up a template file. Then you browse to the template file, open that. Okay. Sorry. I literally did this. Sure. Okay. Where are you going? That's
Blow off some steam.
yeah. Can I join you? Okay. Anyway. So, we will be creating, and this is very important because this is associated with the, well, he's going to miss it, I guess. This is associated with the assignment. There's a very specific way to create a revolved mass in the conceptual mass environment. All right. So if you go, let's hide all of these elements for right now. So either drag from right to left or left to right. Right click, hide in view. Just do elements, that will hide that guy. Okay, massing in sight. In place mass. We're just creating a new conceptual mass. Okay? So, what we're going to be trying to do is essentially create a sphere. This requires us to create a profile just like in a typical revolve in Rhino. It's going to want a axis to revolve around and the curvature of the profile line of the element that we want to actually revolve. So, what we need to do first is create, and of course we have that there. To the right of it, we'll want to create a reference plane. So we want a vertical line to revolve around. So let's create a plane underneath the Properties tab, Reference Plane. Click Drag. Change the name to Centerline. Does she not have the template? It's under Files.
She closed the file.
It's
and
complicated.
when we were saying work in a template, she opened the template.
I mean, it's okay. We're essentially creating we're just creating a new mass.
So can I use a new template right now?
Just do open project and yeah. If you don't know where you saved it, cool.
Yeah, you can.
All we did was move it aside and
Yep. So we want to create a reference plane to then be able to draw our axes on. So we have to go to a specific view. So go to level 1, and then in the left hand side there's a button called plane. Click that. It's up at the top left under properties. Properties. It's the modify. Oh, of course. Now I'm on it. Under modify. Plane. Click. Drag. Click again. And then make sure to name that reference plane. Remember, if you do not name the reference plane, it will not show up when you're going into to set your drawing files under. All right. Everybody caught up? Kind of. You're welcome. All right, so let's go into a elevation. Actually, you know what? Let's go into 3D. Let's get crazy. All right. Go into our 3D view. And then under set, before we hit any line, hit set. And then in the top left, underneath the properties, it'll say placement plane. Right now it's at level 1. Let's change it to that reference plane we just created. All right. And then Revit in the conceptual mass, if you want to revolve a specific geometry, the axis has to be a reference line. So reference planes and reference lines are different. Reference planes are unending planes. Lines are just line work, but they have a little bit more importance. So right above where we clicked reference plane, there's a reference line tab. Let's hit that. And then it should highlight that reference plane we just created. Just click and drag a vertical line. If you want to make it easier, you can click on the cube to go into a true elevation. All right. So now we have the center line of our revolve, our axes. So now we have to create the profile of what we want to actually revolve. Now, Revit in all of its magnificent wisdom, for some reason, does not allow you to connect the profile line, the boundary line, to the axis itself. So if we wanted to create a true sphere, you'd think that we would just create an arc around the axis. You'd think, no. You have, for some reason, you have to have the boundary line and the axes separated somewhat. So it could be half an inch, a foot, but it needs to have some separation between the two. It's a way that Revit computes geometry. It makes absolutely no sense. That's how you gotta do it. All right. Yeah.
Is there any advantage to not doing a full circle?
Not doing a full circle?
Yeah.
No, so like even if you just did a half circle and still connected it at the top, it still won't.
But and if you make a circle with a midpoint and a line, it wouldn't work that way.
No. I mean, you can try out as many different ways to see if you can get it to work. I will say, so when I was in grad school, we had some funky geometry that we were trying to model, and honestly, half of the time I spent in Comprehensive Studio was trying to figure out how to do geometries in Revit, just trying stuff out. So sometimes you're just going to have to do that. Google only takes you so far. Sometimes you just got to experiment. Okay? But for right now, let's just do a half circle. Make sure you leave a little space between the reference line and the profile, and then select both of them, create form, and then it's going to give you an option. So there are two little windows down here. One is just a plane, I believe. The other is a full radius circle. That's the revolve tool. If you select different control curvature, and there are different methods of which Revit can create geometry, whether that be extruding or lofting or just creating a plane, it will give you the option like this. It's kind of arbitrary where the buttons end up, but just be aware that they are there. And if you don't select them, they won't do anything. So hit the sphere. Now we have... It only goes halfway.
So select this and control select that. So when you select both the reference and you have to just select the direction. Just do this. Just make it simple. Now create square with the arrow. Solid view. Now if you go to a corner of six. So what level are you at? No, I'm sorry. What in the process? What step are you at? Okay. So you need to go into maximum height. Okay, so this one over there. So the plane, you have two planes. Okay. Make that plane because you're on top view, you can only see.
Oh, so the plane is like this. Okay, that's why.
So name it something. What's your name again?
Aiden just figured out how to do it. See, this is why we have Ingenuity. So what he did was, instead of creating a half profile like you typically do with a revolve, he actually created the full diameter of the circle, and then click both, create form, and he created a full radius. Essentially, but now there's no space. Let me see if that works for. Just want to see really quick. Has absolutely no bearing on our assignment whatsoever. Of course, that's a lie.
Unselect this, select the regular ones, and then select the drawing the curve the way you did it.
Whoa, look at that.
You just want to draw the edge of the no.
So the one thing with this is that it creates a central plane. So it essentially acts as two different solids. That's okay for what we're doing, because all we need is this outer shell. So we can isolate these two shells and use them to our advantage. I just want to double check that, because you are going to be required to create a custom profile revolve in your assignment. Okay, everybody kind of caught up? All you need is a outside sphere like this. Alright, so select one of the outside faces. I know it splits it in half. That is okay. That's how Revit compromises with its geometry software. Up at the top. So, with current system, you are able to create a rectilinear curtain wall. But if you, let's say, want to create a triangular grid or a hexagonal grid or rhomboid or some crazy, funky other grid, you will use the divide surface tool. This is in the conceptual massing environment still. This is not inside the Revit environment. This is in the conceptual massing. So up at the top, after you've selected the surface that you want to divide, hit divide surface. Whoa! So, now you have this grid system. Now it looks like a typical rectilinear grid. Of course, it actually looks more like longitude and latitude. But underneath the Properties tab, if you have that system highlighted, under the Properties tab, it'll say No Pattern. If you do the drop down, it will give you all the different patterns. Hexagon, triangle. See? Showing you some cool stuff. Yeah. So, right now, let us select triangle bent. So bent, you'll see in a second. But the way that triangle bent versus triangle associate each other, the horizontals of the triangles, well, one of the sides of the horizontals wraps around with the curvature, the flat facets, just like a curtain wall system would. All right. So now we got a triangle grid system, but it has no geometry whatsoever. It has no panels. It has no mullions. That is because it only gives you the pattern. It only divides the surface up into the specified grid geometry. You have to create a custom family that you build the mullion and build the panel into. So we have to go and create a new custom family. So under File and under the new drop down, there's a Family tab. Click that. Now that will pull up all the different types of families that you can create. And there are a lot of them. what we are looking for is the curtain panel pattern based. There is a curtain wall panel. We do not want that. Anybody need me to go over that one more time before I open it? Curtain panel pattern based. It's a mouthful. Do you have to travel back to Berkeley to help? I'm sick. Okay. So now that we have this open, this is the family, this specific family environment. It gives you the an example of the pattern of which you want to create the family around. So since we want to create a family around the triangle bent pattern, we need to change the pattern that's on here, which is that grid system. If you select it, under properties, it'll come up rectangle. If you do the drop down, it will give you all those patterns that we saw before. Select triangle bent. And then it gives you the triangle bent control parameters. So this is kind of like, what was that paneling system we had in Rhino? Where we set up the control points. What's that? You might be right. Yeah, paneling tools. You're right. Be confident, man. It's just like that. So it asks for so essentially what the paneling system or divide surface does, it divides it equally into rectilinear divisions and then associates these control points and the control lines within it onto that rectilinear grid to create either the triangular, the hexagonal, any one of those. So for the triangle bent, we have 4 control points and then a control line that is in the shape of our border of the panel. What we want to do is create a panel and then create a mullion. To create a panel, it is very easy. All you have to do is select the reference line around that is in the shape of the panel, and then up at the top, hit create form. It is going to give you those 2 buttons again. It's either going to ask you to create a plane around that geometry with those lines being the border, or it's going to ask you to do an extrusion. We want an extrusion. Just click that. Now, if you don't click anything after that, you'll see that it gives you a dimension off of the base grid to the top of that extrusion. Right next to that dimension, there's a little dimension icon. If you click that, it will then create a dimension right off of there, and it is now permanent. If you had clicked off, it would just disappear. One way to get that back, in case you did click off, is just click the top face of that panel, and it should pop up again. Everybody follow me? Anybody not? Okay. Now, we can obviously go in, select that top face, and then adjust the height of the panel by using our typical manual methods. But we can make this dimension a parameter. Just like in our mullion, just like in our current panel, we can change the thickness. This is how you create that parameter. You click the dimension tab, make sure it's highlighted, and then up at the top, there's a label. To the right of that label, to the right of the none, it says create parameter. There's a little window with a star at the top right. If you click that, it comes up with your parameter properties. This is where you come up with the name. So right now, this is the depth of our panel. So we can call it panel depth. And then it says you can select either the type or the instance parameter. I've covered this before, but I'll repeat it for the sake of it. Type is associated with the family. If you change the type parameter, it is going to change that parameter across all the different elements of that family. If you have the same floor, it's going to change all the floors. If you have the same wall, it's going to change all the walls. If you make it an instance parameter, it will only change the specific parameter of that specific element. So if you create an instance parameter, let's say, for a thickness of a wall, and you go and click that wall, it will only change the thickness of that specific wall. It won't change the rest of the types of that wall in the remainder of the project. So for our purposes, we'll keep this as a type because we want to be able to adjust the thickness of the panel across the entire system. Make sure that's type. It automatically goes to dimensions since that's what we're editing. So press OK. Give it a second. All right. And now underneath that dimension, instead of just saying 2'6" or whatever the dimension was, now it says panel depth equals. And we can go in and change that under. So now if we try and change it here, I don't think you can. Oh, you could change it. Either way, under properties in the top left, there's a window with 2 or 4 small blue boxes. It's called family types. If you click that, now your panel depth shows up underneath the type parameters, and we can change the depth of the panel there. Press OK. So before we do the mullion, I want to import this back into our project. To do that, before we load it back in, we'll want to save it. Make sure we save it under a name that we'll remember. So let's just say triangle panel. Just saving. Yeah, just go up, save.
Save it as a family?
Yep. File save. It'll default to family since you're in a family editor. Yeah, you can call it whatever. Whatever you can use to identify it. Alright. Everybody save. So, anytime you edit a family, specifically a family, underneath the Modify tab, you'll have Load into Project or Load into Project and Close. Both of those do the same thing. One just closes the family when you do, one leaves it open. Loading into Project, if you click that, it will load into either A, the only project open, or it will give you a list of the open projects that you have, and you can select which ones you actually want it to load into. So that has now loaded that family into our project. If we go to our 3D view, we still have our just our base pattern. That's because it is different. Now, underneath our properties, if we select the pattern and do our drop down, underneath triangle bent, it will say our new family. And if you select that, give it a second. So select the pattern. Oops.
It only fills up half, right?
Yeah, I think it's because of the geometry that we selected. So yeah, so under properties, underneath triangle bent, they should be your new family. Yeah.
Okay.
So this is one of the drawbacks to creating a complete full 360-degree circle, is because up at the top it only has this, so it only has these grids because they're coming all back to the same point. So all of the in-between geometry does not get filled up. For our purposes, it doesn't matter, but I believe, and this is the first time I'm using revolve, so bear with me. I believe if you had that space between the axes and that curvature, you should be able to fully have that panel. At least that's when I did a practice run this weekend when I was setting up the class, that it worked. So, but either way, you can see that those panels loaded in, and then if we go to go back to the go to the family, so the triangle panel, and go to edit type. Underneath the properties, you will see that new parameter, the panel depth that we created. And you can go in and adjust that panel depth. And it will update the depth of panel. Everybody caught up? Good? That's good. Alright. So we created the panel. Now we want to create a mullion. It's a little bit more complicated. So, let's see. So to make this easy, if you're in 2019 or 2020, you'll have all these tabs up here. And if you know which tab to go back to, you can just click it. Otherwise, if you go to View, the View tab, go to Switch Windows, and it will give you all the different views that you have open, and it'll have the project name or family name next to it. Did you do load into project and close? Well, another way to do that is to just go in. I'm just kidding, I can't do that. Never mind, you have to go back to the family. Were you able to toggle back?
Yeah. What's the number of divisions you have on your mass for the triangles?
And whatever it defaulted to. So 12. Yeah, let's 12. Yeah. Alright. Anyway, back in here. So, we need to create a profile along the perimeter of this reference line, essentially creating a loft around or a sweep around the perimeter. Now, to make this easier to visualize, we'll want to hide the panel so we can easily manipulate the profile. So if we tab through and make sure that we have the three-dimensional panel selected and click it, down at the bottom, there's that temporarily hide or isolate. You cannot right-click and hide anything in a family because it's not set up that way. So you need to temporarily hide it. So at the bottom, there's a tab with glasses. If you click that, hide element, and it will disappear. Okay? Alright, one easy way to create a profile is to go up to the Draw tab and actually select the point element. It's not typically used in Revit, but for the families, the pattern-based families, they're very important. The point under Draw tab. Yeah, point element. It's the bottom right. So click that, and then make sure that you click on one of the curves. Now that point is associated with that specific line, and it creates a plane perpendicular to the line. That plane is now what will draw the profile of the mullion around. Okay? Make sense? What's that? So if you click on that point that we just set, you should have a little plane icon. Oh yeah, make sure that you escape once you click. Otherwise, Revit won't know that you're done. All right, so let's draw a circular profile. And to do that, we want to make sure that the drawing plane is set to that specific point. So under Set, the work plane, it'll give you just a pointer, and then we can go in and select that plane. Make sure the plane is highlighted around that point. Click, should be good. Then hit the circle drawing tab. And we'll want the center of the circle to be that point. Draw out. And then just like with the extrusion height, we can make this radius parametric and a parameter. So we'll do the same thing that we did the other one. Highlight the circle. That dimension will pop up for the radius. Click the dimension icon next to it. We'll make that permanent. Then click the dimension under label. Hit create parameter. Mullion radius. Press OK.
What did you do to create that parameter?
So you click the dimension, and then up at the top right, you'll have a label, and then to the right, create parameter. So, yes.
No.
Okay. Apparently, do you not want my help?
I mean, I'll take your help, but I don't want to make you lost over here. Bring your computer over there.
Yeah.
He said click on the dimension.
The dimension.
That's this one right here?
So that makes it permanent. So if you click off right now, now it's permanently there. Then you can click that dimension. Oh, you're going way above and beyond. Huh. Yeah, I'll hire her as my TA next time. Okay, moving on. So, now we have our profile line. We have our we have our rail for our sweep, which is this outside boundary. Click that guy, and click the profile line, both at the same time. And then up at the top, hit create form. There's no other geometry other than a sweep to create, so it automatically does it for you. But since we created the parameter around the radius, the profile line, if we go into our parameters and adjust our mullion radius, it will update to the sweep that we created. It's all based around control curves, control lines. Okay? Yes, sir. All right. So now we can reset the temporary hide isolate to give us our panel again. And one thing before we go, so not only can you create parameters from dimensions, you can also do materials. So if you select the panel, the entire solid geometry, it'll give you an option for a material. So you can either change that by going in, changing and updating the material, or there's a very tiny gray button next to the name of the material. It's very obscure. I don't know why they make them so tiny. But if you click that, it will come up with a family parameter, just like the label for the dimension. At the bottom left of that panel is a create panel button, little page with the star. Hit that. Then we create, let's say we have panel selected, so panel material. Press OK. Press all right. Now that has an associated material, and then we can do the same thing for the mullion. Make sure that you select the entire mullion geometry. Click that guy up in its properties under material. far right, there's a gray button. Click that. Family parameter tab comes up. Bottom left, hit new parameter. Mullion material. Now, for fun, let's change this from a type parameter to an instance parameter, just to be able to visualize the difference. Press OK. Press OK.
So, for the mullion material, I pressed OK before you mentioned changing the instance.
Okay, that's fine. So, at the top left, under Properties, there's the Family Types tab. If you click that, that will bring up all the parameters associated with this file, including our mullion material and our panel material. If you select one of those, on the far left, just click on the name. At the bottom left, there is a little pencil. It's Edit Parameter. That will then open up that parameter tab again.
What did you first click on?
Top left corner under Properties is like 4 blue squares. Bottom right.
And then I go to the mullion material.
Yeah, so just select the mullion material, and then in the bottom left there's a pencil, Edit Parameter. And then you can go edit those.
All right.
Dun, dun, dun. Okay. Alright, so now that we have those all created, let's save our family type. And then load into project. Overwrite the existing version. Please don't give me errors. Okay, so just OK through the errors, then go to our 3D view. Does it disappear? God damn it.
Yep.
Oh, that's weird. I don't know why that just happened. Gotta love Revit. So all I did was go to the other half and divide the surface again, and then select the triangle panel. And then they both showed up. Mine are different because I have different. What's that? Yeah, so when you load your new file back into the project, the mullion and the panel will come in. You loaded it back into the project?
Oh, yeah.
I still have.
I just really need help.
Bro, that's you.
Nice. And I'll have all the time I need for
Yeah. All your friends will probably be preparing for that. You go to the gym or something. Nice.
No, 8,000
Oh, you're drafted though.
Yeah.
I would like when you graduated. Like
It's
like
not
that.
flat.
Like I've gone over those.
It's like the one line and
Yeah.
it's crazy. Yes, overall, but like the, things like, it would be good to have the lines and,
I like it when that's like it when
this is
that's.
what we gave me, I'm
Do you really? You're in America.
Yeah, with these exams, it's like, yeah, a little bit less than half.
Yeah,
Especially if you go to like in-house certification, that's like higher, like 60 days sometimes. But or the other exams, 40s, maybe low.
Yeah.
If
I have that chance. Yeah.
You don't, you go to
Like,
the
I
high school, like,
You don't get
people,
No, I wouldn't have 1,000%. I would like more accuracy. Because you're gonna get 50%. Well, actually, you
This is way better.
yeah, but she wants you to do half an hour now for a year, and you do like.
But
You
soon should other
use good stuff out of the world. Then you come back to studio and be in that place for 4 hours straight.
Yeah,
That's true.
it's easy because like
The last one.
This semester.
You still got a year.
It's not bad. You don't get it though.
I will do it. Also, I think.
All of us.
No presents for me.
Yeah,
he's with me.
yesterday, honestly, he's like, I should trust this character here.
Yeah, I don't
She like has trouble with PhDs. You wouldn't know when the sentence started, where the middle is, or when. You just have to kind of piece together what you say. She's smart. She's really smart. She's like smart.
Oh,
Yes.
No, no problem.
So I got this. But
It's not easily.
what are your lines there?
It's my reference. So where the wall.
Oh.
What I do.
Ryan, you should overdo it to quality. What? What? And put that in place. In your shape up. Shape
Yeah.
Should have had this cat before you because
right now you do it's making you do something that's not related.
What happened to me?
Just like screenshot that.
Can you resend the picture?
This is what I have. I'll get it to you.
No, I didn't even take my last document.
You said that?
Yeah. No,
Okay. So 7:30, we are good. We are
Oh, we're done?
for right now. The one thing I wanted to show you is, remember when we made the mullion material an instance parameter? So if we go under the system type, under edit type, it does not show up under the materials and finishes parameter. That is because we have to actually go in and select each individual panel that we want to change the material of, and in that panel's properties, under the materials and finishes tab, it has the mullion material parameter that we created, and you can adjust that based on any different type of panel that you select.
I think, for instance, you didn't say that in the
Yeah, so that's what I was showing earlier. If you go back to the family, under the properties up here, there's a family types. That'll show you all the different parameters within the family. And then if you select that parameter and go down to the edit parameter, this little pencil tab, that brings back up the properties, and you can change it to instance. All right. Any questions? I know, obviously, computers are weird. So that is all based around the geometry. So because it cannot rectify, oh, everybody's talking. Because it cannot rectify these panels up here because there's no space for the other panels. That's why it doesn't create one. It negates the entire rest of the surface where those panels will be created. So if we created, here, let's go back. Just really quick. We still have our reference curve. And we revolve this around. Of course not. Why would it do that?
So could it be doing that because we only made one instance of a panel instead of multiple instances, like it has in the other typologies?
In regards to what?
In the other typologies that it has underneath the system, so under the triangle event, it shows multiple triangles. Could be because we only have one in the family, it only recognizes one instead of filling out the rest of the way.
I don't believe so. Let me just create a really flat one. Yeah, it has something to do with the geometry. If you run into this, so we'll go over the assignment now. If you run into this in the assignment and it only creates, that's okay. I mean, try your best to try and figure out how to adjust it and make it work. But if it can't work, can't make it work, then just submit a checkerboard. All right, so assignment 3, building the gherkin again. Calm down. We are not getting as complicated as we did with Rhino. All right? No. So we're not, we're not drawing the solar chimneys. We're not doing any crazy detail. All we are doing is creating the conceptual mass in the form of the gherkin tower. All right, and then we're creating mass floors associated with that mass. So you have to create the levels, all the levels associated with the gherkin, create the mass floors from it. Then create a floor type. Doesn't matter the thickness, doesn't matter the structure, as long as it shows up orange. So change the material, something that is orange. Then, within the conceptual massing environment, divide the surface of that geometry into a diamond grid. Then, like we just did, create a new current panel pattern-based family. And instead of the triangle bent, it will be the diamond pattern that you select. Then create a mullion, general size of the beams. Change that material to something that's green. And then change the panel, create a panel that's in the shape of that diamond pattern. And a thickness appropriate for glass, which is generally 1 inch. And then apply a material that is both blue and 50% transparent. And then apply that family to the gherkin model. And then just like in other assignments, need a section, dimension each level, elevation, dimension each level, floor plan, dimension all the features that you can. So panel width, the radius of the gherkin, whatever floor you're on, etc. And then a section perspective and a 3D axonometric. Okay, you can export those or print those from the views themselves, just like we talked about in the beginning of the class. The colors are to make sure that you, so that Allah can identify them pretty quickly and easily within the PDFs. That is the primary goal. Okay? Any questions? All the relevant drawings and imagery are in the files under a folder called Gherkin.